Ever stop and really think about what it takes to bake millions of perfect cookies every single day? It's a number so big, it's almost silly. We're not talking about your corner bakery here. We're talking about a sprawling mega factory, a city of steel and automation that cranks out over 40 million cookies every 24 hours. This is an operation where precision is everything, where mountains of ingredients are transformed into the neat little packages on your shelf. The scale is just staggering. In one day, a factory like this can make enough cookies to lay them end to end for hundreds of miles. Today, we're pulling back the curtain. We're taking you on a journey deep inside one of the world's most efficient cookie factories to see how it all goes down. From colossal silos packed with flour, to literal rivers of chocolate, and through baking tunnels the length of a football field, you're about to see the mesmerizing dance of machines that satisfies the world's sweet tooth. This is the story of how a simple cookie gets made on a not-so-simple scale. Chapter 1. The Foundation, Mountains of Raw. Ingredients. Every cookie starts with good ingredients, but in a mega factory, that also means a mind-boggling amount of them. The journey begins not in a pantry, but at a towering farm of silos that scratch the skyline. These metal giants are the first stop, holding the lifeblood of the entire operation. Hundreds of tons of all-purpose flour, kept perfectly dry and fine by a climate-controlled system. It's less like storage and more like a science experiment. Just as important are the sugars. In separate, equally massive silos, you'll find mountains of the stuff. Finely ground caster sugar is a main player, but there's also granulated sugar for that perfect snap, and pallets of brown sugar for when you want a chewier, moister cookie. Before any sugar joins the party, it's often pulverized in industrial grinders to make it extra fine. It's a small step that's crucial for creating a smooth, uniform dough. And then, you need the fat. It's what makes a cookie tender and gives it that melt-in-your-mouth quality. While you might use a stick of butter, this factory uses liquid tankers and solid blocks of shortening by the ton. The shortening is stored in rooms chilled to a precise 8 to 10 degrees Celsius. That temperature isn't a suggestion, it's a rule. Too warm and the shortening gets oily. Too cold and it gets lumpy. This obsession with temperature is one of the first secrets to factory-level consistency. Alongside these big three, you've got huge vats of pasteurized liquid eggs, vanilla, and corn syrup, all ready to be piped directly into the mix. Then you have the supporting cast, pallets loaded with salt and baking powder, the leavening agent that gives cookies their lift and delicate crumb. And let's not forget the best part. In a special, climate-controlled warehouse, you'll find colossal containers filled with tons, literally tons, of chocolate chips, nuts, and other goodies, all handled with care so they don't break before they even see the dough. Just managing these ingredients is a monumental task, a complex circulatory system of pipes and conveyors run by computers calls up the exact weight of each ingredient and sends it on its way. Nothing is left to chance. Every gram is accounted for, ensuring that the first cookie of the day tastes exactly like the millionth. Chapter 2. The heart of the factory, the mixing room. If the silos are the pantry, the mixing room is the factory's heart. This is where science and brute force come together to create the soul of the cookie, the dough. Forget a bowl and a wooden spoon. We're in the domain of colossal industrial mixers that can whip up anywhere from 100 to 10,000 kilograms of dough an hour. This is where the ingredients finally meet in a carefully choreographed three-step process. First up is creaming, and it's arguably the most important step for the cookie's final texture. The perfectly chilled shortening drops into the mixer, followed by the sugar. As the mixer's powerful arms whip them together, they're not just mixing, they're aerating. The sugar crystals create millions of tiny air pockets in the fat, which will expand in the oven and give the cookie its light, tender bite. This is also when other key ingredients like salt and baking powder are added. Once the mix is light and fluffy, it's time for stage 2, adding the liquids. A computer-controlled system releases the exact amount of liquid eggs, water, and vanilla. The mixer keeps churning, making sure everything is perfectly blended. All that friction creates heat, so the mixing bowls are often surrounded by glycol-chilled jackets. The dough has to stay at a cool 19 to 20 degrees Celsius. If it gets too warm, the fat will melt, and you end up with a greasy, dense cookie that won't hold its shape. The third and final stage is the most delicate, adding the flour. A massive quantity of flour is piped in and gently folded into the wet ingredients. The mixer slows way down for this part, which often lasts less than a minute. The goal is just to combine everything. Overmixing here would be a disaster, creating tough gluten, great for bread, but the enemy of a tender cookie. If the cookie calls for chocolate chips or nuts, they're tossed in at the very last second, folded in just enough to distribute them without crushing them to dust. The result is a huge, uniform mass of cookie dough, perfectly aerated and temperature-controlled. The giant mixer tilts, and this enormous batch of potential is deposited onto a conveyor belt, ready for the next step, getting its shape. Chapter 3. From dough to disc. The art of forming. That colossal blob of dough is now on the move, traveling down a wide conveyor belt into the forming section. This is where pure mechanical artistry transforms the shapeless dough into millions of identical discs. The dough is fed into enormous hoppers, which funnel it down into one of several highly specialized machines. A common method for patterned cookies is the rotary molder. Picture a giant, engraved rolling pin made of bronze. The dough is forced against this rotating cylinder, which has the cookie's design carved into it. A rubber roll presses the dough into the cavities, a blade scrapes away the excess, and then a conveyor belt pulls the perfectly formed raw cookies out of the molds. They drop gently onto the main oven band, perfectly spaced and aligned. The scrap dough, it's instantly sent back to the hopper to be reused. Zero waste. For cookies with big chunks of chocolate or nuts, you need a different approach. The wire cutter. A rotary molder would just crush the good stuff. Instead, the dough is pushed out through a die, forming a long log. A taut wire then slices through the log at incredible speed, cutting off perfect, uniform cookies that drop onto the belt below. Some of these machines can make 150 cuts a minute, producing a whole row of cookies with every slice. A third method for softer doughs is depositing. Think of it as a giant, automated piping bag with a row of nozzles. The depositor pushes out perfectly portioned dollops of dough onto the moving belt, ready to spread out in the oven. No matter the method, the result is the same. The river of dough has become an endless, orderly army of raw cookies, marching in perfect formation. They are now heading for the most dramatic stage of their journey, a trial by fire that will forge their final character. They're heading for the baking tunnel. Chapter 4. Trial by fire. The baking tunnel, the army of raw cookies, marches forward, approaching a steel behemoth that dominates the factory floor. The tunnel oven. These things are engineering marvels, some stretching over 100 meters, longer than a football field. As the cookies cross the threshold into the glowing amber heat, they begin a journey that will last only a few minutes but will change everything. This isn't just a hot box. A modern tunnel oven is divided into distinct zones, each with its own precise temperature and humidity. In the first zone, the heat is cranked up, maybe to 250 degrees Celsius. This initial blast makes the baking powder react and the water turn to steam. The expanding gases cause the cookies to rise, creating that light, airy texture. As the cookies move into the middle zones, the temperature might drop slightly. The focus here is on baking the cookie through and developing its color and flavor. This is where the Maillard reaction kicks in. The chemistry that creates that golden brown color and rich, toasty flavor. It's a delicate balance, and operators are watching constantly. Powerful vents suck out the steam released by the cookies. Otherwise, they'd get soggy instead of crisp. The final zones are for finishing. The temperature decreases, again allowing the cookies to dry out to the perfect moisture content. This is what determines whether the cookie will have a hard, snappy crunch or a firm, chewy bite. The whole trip through this inferno is surprisingly fast, sometimes just 5 or 6 minutes. Sensors are everywhere, feeding data to a central computer. Thermocouples measure the temperature to a fraction of a degree, while infrared scanners check the color of the cookies, making tiny adjustments in real time. This is how the factory achieves such mind-blowing consistency. Finally, the cookies emerge from the far end of the tunnel, golden brown, fragrant, and fully baked. But they're also incredibly fragile. The sugars and fats are still almost molten, making the cookies soft and pliable. They aren't finished yet. They have to survive one more critical stage, the big chill. Chapter 5. The big chill. Cooling and solidification. Coming out of the oven, the cookies are delicate. The sugars and fats that make them delicious are still semi-liquid, and if you tried to package them now, they'd just fall apart. That's why the cooling process is just as critical as the baking. The river of hot cookies moves from the oven band onto an even longer series of cooling conveyors. These are often made of open wire mesh to let air circulate all around the cookie. The conveyors snake back and forth across a huge area or even rise up into multi-tiered towers to save floor space. This isn't just about waiting. Banks of industrial fans blow filtered, room-temperature air over the cookies to cool them down rapidly and evenly. If one part of the cookie cools faster than another, it can create stress and cause it to crack later on. A hidden defect that can ruin a product. As they travel, a transformation happens. The molten fats and sugars start to crystallize and solidify. The soft, pliable disc becomes the firm, crisp treat you'd recognize. The smell in this part of the factory is just incredible. A warm, sweet cloud hanging in the air. The length of the cooling line is calculated with absolute precision. It has to be just long enough for the cookies to cool to room temperature before they hit the packaging line. If they're even a few degrees too warm, it can spell disaster for their shelf life. After their long, winding journey, the cookies are finally stable and ready. For some, the journey is nearly over, but for others, an extra layer of deliciousness awaits. Chapter 6. The finishing touches. Creaming and enrobing. Now that they're baked and cooled, some cookies are ready to be packaged. But the lucky ones are heading to the finishing department, a place of mesmerizing precision where they become cream-filled sandwiches or chocolate-coated treats. Let's follow a sandwich cookie. The cooled cookies arrive in perfect rows and are fed into a machine that does something ingenious. It automatically flips every other row over. Now you have alternating rows of cookie, bottoms facing up and tops facing down, ready to be paired up. The rows of cookie bottoms pass under a cream depositor. A stencil lowers, and a set of nozzles deposits the exact same amount of fluffy cream filling onto the center of each one. The moment the cream is down, the cookie tops, traveling on a parallel conveyor, are gently placed on top. The pressure is just right. Enough to stick, but not enough to squish the filling out the sides. This whole thing is a blur of motion, assembling thousands of sandwich cookies every minute. For cookies getting a chocolate bath, the journey is different. They line up on a wire mesh conveyor and head for the enrober. First, a bottomer runs them over a wheel rotating in a pool of tempered chocolate to coat their undersides. Then comes the main event, the chocolate waterfall. The cookies pass through a continuous, shimmering curtain of liquid chocolate that covers them completely. The temperature here is critical. The chocolate has to be perfectly tempered so it has a beautiful gloss and a satisfying snap when it cools. As they emerge, a jet of air blows off the excess chocolate, leaving a smooth, even coat. Immediately after, the cookies enter another cooling tunnel, this one colder and designed to set the chocolate fast. After a few minutes, the chocolate shell is hard and glossy. The cookies, now in their final, most decadent form, are ready for their last judgment. Chapter 7. The Unblinking Eye, Quality Control. Throughout this whole process, an invisible layer of scrutiny has been watching. But now, the cookies face a dedicated quality control gauntlet. At this scale, manual inspection is impossible, so the factory relies on some seriously smart tech to act as its unblinking eyes. The first line of defense is a series of high-speed cameras. As the cookies stream by, these machine vision systems scan every single one, comparing it to a golden standard for the perfect size, shape, and color. Is a cookie slightly too brown? Is a sandwich missing its filling? If a cookie isn't perfect, the system flags it. A few feet down the line, a puff of air gently nudges the reject into a bin without ever slowing down the line. Weight is also critical. Every stack of cookies passes over a highly sensitive scale. If it's even slightly underweight, it's rejected. This not only protects the customer, but also helps the factory spot problems upstream. Next comes the most critical safety check: metal detection. Every single cookie passes through a detector that can spot a microscopic fragment of metal. If anything is found, the machine rejects the cookie and sounds an alarm, triggering a full investigation. Some factories even use X-ray systems that can spot non-metal contaminants like glass or plastic. Beyond the machines, a human quality control team is always at work. They pull samples from the line to test in a lab. They measure a cookie's snap, check moisture content, and conduct taste tests to make sure everything is perfect. They're the human gut check for the automated systems. This multi-layered system of automated inspection and human verification ensures that out of the millions of cookies that started the journey, only the absolute best make it to the finish line. Chapter 8. The Final Sprint, Automated Packaging. The cookies are perfect. Now begins the final frantic sprint to get them safely sealed and ready to ship. Welcome to the packaging hall, a symphony of whirring servos, hissing pneumatics, and rustling plastic. The cookies arrive in their neat rows and are gently jostled onto their edges by stacking machines. Mechanical arms count out the exact number for a package and push them forward into neat stacks. These stacks are then fed into a horizontal flow wrapper. A sheet of plastic film is formed into a tube around the cookies, sealed and cut, creating an airtight package in a split second. Some of these machines can wrap hundreds of packs a minute. The wrapped packs continue on to be boxed. A robotic arm with suction cups might grab a group of them and place them into a cardboard box that was just folded into shape by another machine. The box is sealed with a dab of hot glue, but we're not done yet. These boxes are then sent to a case packer, where a larger robot arranges them inside a big shipping case. The case is sealed, a shipping label is automatically applied, and it's sent on its way. The final step is palletizing. A massive robotic arm picks up the shipping cases and stacks them onto a wooden pallet in a pre-programmed pattern for stability. Once the pallet is a perfect cube of cookies, a machine wraps the whole thing in plastic stretch wrap. This finished pallet is then whisked away by a forklift or an automated vehicle to the warehouse, where it joins thousands of others. They won't wait long before they're loaded onto trucks and sent to stores, maybe thousands of miles away. From a mountain of flour to a pallet, ready for the road, the whole journey took only a few hours. It's the kind of massive, satisfying process we find fascinating. If you think the precision of these machines and the sheer scale of it all is as cool as we do, make sure you subscribe and hit the notification bell. You won't want to miss where we're headed next. So, the next time you open a pack of cookies, take a second. Think about the colossal mixers, the 100-meter-long ovens, and the tireless robots that all played a part. What starts as simple flour and sugar is transformed through a perfectly synchronized symphony of automation into a small, simple moment of enjoyment. In the world of mega factories, that's how millions of perfect moments get made, every single day.